In the last video, we got introduced to the idea of unit circle. So unit circle is a circle whose radius is 1 centimeter or 1 meter, or it can be anything which is 1. And we happen to consider this angle to be theta and this point to be, say, a comma b. So we establish a relationship between a and b with theta as cos of theta and sine of theta. So indirectly, what we are trying to tell is, I can find the value of a, that is a point P's coordinate. I can find it. I can find point P's coordinate with the help of cos theta and sine theta, that is by knowing theta and applying this trigonometric functions. So all of this is good for your first quadrant, Now we're looking at values which are behind the first quadrant, 90 plus basically. So first thing is, do those values exist? Do we have sine of 120, for example? So I'm typing in 120. These are in degrees. The sine of this value turns out to be 0.866. So it does exist basically. So it is a real set of values. We do have these values. Now, what is the nature of relationship between sine and cos with a and b in other quadrant? What I mean is, if I take up a random point over here, over here, over here, over here, what kind of nature of relationship are we looking at? Is it as simple as a and b being equal to sine and cos? That is, if I take up an angle over here, right, it looks to be around 120 plus, say 125. So I know this angle to be 125 degree. Now, can I just use cos of 125 and sine of 125 and find this quadrant? Not quadrant, sorry, find this coordinate. That is the question we are trying to answer. Okay, so first thing is, does it exist? Yes, it does exist. Such values does exist. So what is the nature of relationship is what we are trying to look. So that we're going to do with the help of our Python coding. So this is a code which, as you can see, generates, can you guess what? Think about it. Okay, let me explain. We are looking at a unit circle. Right, on this unit circle, I have a red dot which is on this running around the circumference of the circle as and when I move the mouse. Right, I'm moving the mouse. So according to the mouse, this line is being drawn, and the coordinate where this line and the circumference of the circle meets, at that point I'm having a red dot. Right, this coordinate is found and displayed over here, and this is the respective angle. For example, if I go around angle of 30 degree, right, you can see that it's around 30 degree, and the red dot is at a point 0.86 comma 0.51. That is nothing but your sine 30. Sine 30 is 0.5 and sine cos 30 is 0.86. That looks to be right. So a similar set of values is found in different quadrant, okay, in this program. So what I'm trying to show you guys is what kind of coding I have done. What is that mathematical expression I've used to do this? So I've done it over here, right, defining red dot's coordinate. This is the function which gives you the coordinate of that particular dot. So this is what I'm doing. What is that I'm doing? X is equated to some value plus radius into math dot cos of an angle. See, center is a fixed value. Center is fixed over here. Can you see that? Center value is fixed. It is to do with the center of the circle on the screen. Okay, whatever you saw now, the center is exactly over here and all of that. So you guys don't have to think about it. And the radius being, it's not a unit circle. So anyways, cos and sine value is between -1 and 1. So all of these facts put together, I have this expression. The point is, I'm able to calculate x and y for all the quadrant using this. I don't have a condition. You're not looking at any condition that the angle between 0 to 90 will be calculated this way, 90 to 180 calculated this way, nothing. I'm just using this and I'm finding the x and y value by knowing the angle. So what is that I can conclude? The nature of relationship is very simple. It's a straightforward relationship. Okay. Throughout this how do I put it across? Throughout this region, right? The nature of relationship is A and B in all point P's A and B in all quadrant can be found using what? Yes, using sine of theta, comma, cos of theta. So in this case, yes, we are able to establish that this is cos of 120, comma, sine of 120. Okay, this coordinate can be found with the help of this angle using trigonometric functions is what we established. So that is the funda. So we are very sure that this is what is happening over there. Okay, and the next thing that we have to learn is how can we derive it using the concept that we already know, using the values which we already know. So before we start off with that, let me recall few things. So we are looking at quadrant. So there are 4 quadrants in this 2-dimensional structure. This would be your first quadrant, that's your second, third, and this is fourth, right? We are going anti-clockwise. So we need to understand that the axis it's not on any quadrant. It's not on first or second, nothing. The axis values are not on any quadrant. So between 0 and 90 is your first quadrant, 90 and 180 is your second quadrant, between them, not including them. Okay, this fact you guys have to remember. So that's the first thing. Second thing is nature of values in the quadrant. All of this helps. So let me put it across in a neat manner. So this is first, second, third, and fourth. Now the next question is the nature of values in each quadrant. That is, what kind of values are we looking at here? Plus and plus. Over here it is, yes, minus and plus. Over here, yes, it is minus and minus. Over here it is, yes, plus and minus. Plus y plus because it's on the right, and y minus, it's down. So it's plus and minus. And so we have this following things that we have to know. And now the actual core thing, that is deriving the values of different quadrant in coordinates in different quadrant from the first quadrant. Okay, so now we are going to figure out that, say I have a value point B, which is a comma b, not a, point P, making an angle of theta, right? How can I relate it to something which is over here? Say this is a point again, point say Q, M comma N, and this is, okay, so this is where it gets tricky, not tricky actually, this is where the concept gets clearer actually. See, this is 90 plus theta, 90 is still this line, plus theta is this, so basically this angle is how much? Yes, theta. Okay, does it make sense what I'm trying to do? Now, how is that I'm going to do this? I'm going to do this with the help of your old friend congruency. Okay, I'm going to drop the set of triangles, altitude actually, and thus I have a triangle. Say this is O, A, P, and this is O, M, and Q. So we have this set of triangles, and are they congruent? Yes, they are congruent. Is it not? So triangle OAP is congruent to triangle OMQ by, this is because of, yes, AAS, congruency. Now with CPCT, what and all can I tell? By CPCT, that is congruent parts of congruent triangles, corresponding parts of congruent triangles, what and all can I tell? I can tell that OA is equal to OM, right? And OP is equal to OQ, and also I don't have space, I'll write it over here, AP is equal to MQ, right? I just want to establish this side values. Angles will not matter. Side values is what I want to establish. So I have written this. Now let me express in terms of A and B. OA is nothing but A, right? OA is A, is equal to OM. OM is over here. What is that? N, not M, it's N. It's Y component. So A is equal to N. Now also we have AP is your B, which is equal to AP is equal to Q NQ. Okay, NQ is nothing but your X component, right? X component, which is nothing but your M. Please understand this. This is where it is going to get tricky for you guys. Please understand this. Just look at the figure, because after this it's just a conclusion. Now I'm going to write something that you guys have to listen to it very carefully. See, these two triangles are congruent. All of these are equal in terms of magnitude. That is, their lengths are equal. While when you talk in terms of coordinate, right? So in terms of coordinate, sorry, let me establish this. In terms of coordinate, okay, what is happening over here? Let me show you guys, explain it to you guys. A, which is left to right, is equal to N, which is up. Okay, so that's not an issue. B, which is up, is equal to M, which is to the left. Means what? This is negative. Okay, or negative of this is that. Please understand this. If this is, say, this looks to be around 5, 2. What will this be? This will be, think about it, this point Q will be then, as per this value, 2, 5 or minus 2, 5, which is right. It's minus 2, 5. Does it make sense? Please think about it. Take a second, pause it and think about it. Does it make sense? So the values between the A and N are direct, both are positive, not an issue, while B is negative of M, or I can tell M is negative of B. Anyways, the point here is, it's a very clear relationship that M comma N is equal to minus, sorry, not minus, oh yeah, minus only, minus B comma A. Okay, this is what you guys need to understand. Till here, if things are clear, then the next part is not that hard. Okay, so the next part is, now I'm going to use trigonometric ratios. So what is that I'm trying to do? See, in place of A, I'm going to write cos of theta, and in place of B, I'm going to write sin of theta. We saw that, right? I will establish this again with the help of this particular code. Here you can see X is NP cos of theta and Y is NP sin of theta. So X and Y are being plotted, and I'm going to plot from 0 to 2 into pi, basically 0 to 2 pi, that is 360 degree. Okay, what is this 100? You guys don't have to think about that. For now, let's look into this, and we got a circle. Along the X, I have listed cos theta. Along Y, I have taken up sin theta, and I have this set of values. So again, I can find any value by knowing theta. So this is cos theta and sin theta because angle is theta. While for Q, I'll write it over here. It is cos of 90 plus theta, because that's the angle, is it not? From the x-axis, remember, yeah, it has to be measured from the x-axis. And this is sine of 90 plus theta. Okay, can you see that? Right? Now, let me substitute it over here. In place of M, I have to write over here cos of 90 plus theta. In place of N, I'm writing sine of 90 plus theta. And this is equal to B, which is B is what? Sin theta, minus B is minus sin theta. And A is what? A is your X, that is cos theta. Okay, so end of it, let me write it a bit neater. So end of it, what can I tell? I can tell the following. Cos of 90 plus theta is same as finding minus 1 into sine of theta. And sine of 90 plus theta is same as finding, yes, cos of theta. So I'll give an example now. Example, cos of 90 plus 30, that is how much? Cos 120 is minus 1 into sine of 30. Okay, so sine 30 is what? Minus 1 into sine of 30 is half, 0.5. Okay, agree? Now sine of 90 plus 30 is equal to cos of 30. It's a very straightforward relationship, which is root 3 by 2. Right? So sine cos 120 is minus 0.5. That makes sense. And sine 120 is root 3 by 2. Let me confirm it with the help of maybe this code or even calculator. You guys can do that. I'm going to run over here. So 120 is, yes, that's 120. Can you see that? What is the value? Cos is minus 0.5 approximately. Sine theta is 0.86. That is root 3 by 2. And we have the right values. That's it. Right? So we are able to find the value of the second quadrant by establishing a relationship which is nothing but this. So you guys have to remember this. Cos of 90 plus theta is minus 1 into sine theta. Sine of 90 plus theta is same as finding cos of theta. Okay guys. So next, third and the fourth quadrant, I'm going to tell it in a different video. It's already long enough. So you can pause and copy everything. This is very important. Don't miss anything. Take up compass, protractor, whatever you guys want. Draw it neat. Use color pencil, sketch pen, whatever you guys want. Please write it neat.